All right, in lesson 6.5, we will be working with linear inequalities and also graphing linear inequalities. The first type of problem you will see has to do with identifying a solution or a number that makes it true, a solution of a linear inequality. So for the first example, we want to know, is the ordered pair a solution to this inequality? So what we do is we plug in the ordered pair to see if it makes it work, to see if it creates a true statement. So instead of y, we're going to say 2. 2 is greater than, instead of x, we're going to say 1 minus 3, and simplify. Write everything as is, and 1 minus 3 is a negative 2. 2 is greater than a negative 2, so this is a true statement, meaning yes, this is a solution. And this would be our answer. True would not be our solution. True would not be our answer here because it's asking, is it a solution? So we would need to say, yes, it is a solution because this is true. For the next one, now we just have a different ordered pair to plug in. So instead of y, we're going to say negative 7 is greater than, instead of x, we say negative 3 minus 3. Continuing with the inequality, negative 7 then is greater than, negative 3 minus 3 is negative 6. Negative 7 is not greater than negative 6 because it's a larger negative, meaning it has a smaller value. So this is a false statement, meaning no, it is not a solution. For our answer, it is not a solution. It does not make it true. So let's see an example where we have fractions instead. We treat it the same way. We plug 3 in for the x value, 6 in for the y value. So we would say 6 is less than or equal to 2/3 multiplied by that x value of 3 plus 4. And we need to simplify it. Nothing to simplify to the left of our inequality symbol. We can write this 3 over a 1 to multiply. We know that 2 times 3 gives us 6. 3 times 1 is 3. We can simplify that shortly. So then we have 6 is less than or equal to 2 plus 4. 6 is less than or equal to, keeping that sign the exact same all the way down. And because, yes, it is or equal to, this is a true statement, meaning it is a solution. However, if our inequality would have been just 6 is less than 6, it is not less than 6. So in this case, it would not be a solution. But for our specific problem here, what it's asking, it's less than or equal to, so that or equal to makes it a solution. It makes it true. The second type of problems you're going to be seeing have to do with graphing inequalities. When we're graphing inequalities, we have to distinguish between the less than and greater than, and the less than or equal to and greater than or equal to. To do that, we use dashed lines for just less than or greater than, showing that it is not equal to the numbers on the line. And when it is equal to the numbers on the line, then we use a solid line to differentiate. So we want to make sure that we're being careful with that as we solve these problems. The first type of problem we're going to solve is similar to the one we've been checking for solutions. It has 2 variables. This is on page 391 in your book. To do this, we treat this originally just like it would be an equation, and we need to graph it. So in this case, our y-intercept is negative 2. Our slope is a positive 1, or 1 over 1. So we can graph that. It's just a greater than symbol, so it needs to be a dashed line. That's an easy thing to forget, so you always want to double check. It's a greater than symbol, not equal to, so it's a dashed line. Our y-intercept at negative 2. Our slope of 1 to 1. We still line up our ruler the same way, but we just have to make sure that in these, for these types of problems, that we just create a dashed line. So making spaces as we go. Because it's an inequality, there can be a very large range of ordered pairs that make this true. To check to see if it's all of the ordered pairs above the line or below the line, we can pick an ordered pair that's not on the line. The easiest ordered pair to use is 0, 0. So to check for shading, we plug in the ordered pair 0, 0. So for our y, we have 0 is greater than, x is also 0, minus 2. When we simplify that, 0 is greater than negative 2. This is a true statement, meaning that 0, 0 is a solution. So because this is a solution, we would want to shade that side of the line. 0, 0 is above the line, so we're going to shade everything above the line, meaning everything up here would create a true statement or is a solution to this inequality. And that line would continue going, so we need arrows at the end. Let's try the next one. Again, to draw the line, we treat this just like an equation. Our slope is 1/2. Our y-intercept is a positive 1. This time it's less than or equal to, so because of the or equal to sign, it's going to be a solid line instead of a dashed line. We plot our y-intercept at 1. Our slope, rise over run, we rise up 1, run 2, rise up 1, run 2, fall 1, run negative 2. And this time, again, double check, it's a solid line, so we can just draw that one like we would normally. And draw arrows at the end. And again, we need to see which side contains all of our solutions. Is it above or below our line? We want to use an ordered pair off the line to check. So in this case, 0, 0, again, is not on the line. We wouldn't have to use 0, 0. We could use, let's see, we could use negative 2, 2. We could use 0, 3. Any ordered pair that isn't on the line, we can use. 0, 0 just typically ends up being the easiest numbers to plug in. So let's check that ordered pair. The y is 0, less than or equal to 1/2 times the x is also 0, plus 1. Then we simplify. Anything times 0 is 0, plus 1, and we have 0 is less than or equal to 1. Also, a true statement, so this is a solution. So if 0, 0 is a solution, that means everything on this side of the line is also a solution. So we're going to shade everything below the line. If we would have plugged in the ordered pair 0, 3, let's see what happens. For the y value, we need 3 is less than or equal to 1/2 times the x value of 0 plus 1. We simplify. Again, that turns to 0, and we have 3 is less than or equal to 1. This is a false statement, meaning it's not a solution. So because it is not a solution, we wouldn't want to shade the side of the line with this ordered pair. So we would want to shade the opposite. 0, 3 is not a solution. It's above the line, so we would want to shade below the line, again confirming what we found before. The final type of problem we'll see is graphing a linear inequality that has just one variable. We've graphed equations with just one variable. Now it's just going to be an inequality, so we have to keep in mind, is it a dashed line or a solid line? And then also our shading. So for this first one, x is greater than negative 1. So we need to find x at negative 1. X is negative 1 here. X is also -1 here. The value of X on the X-axis is also -1 up here. And we can get another one. All of these values are -1. It's a greater than symbol, so that makes it a dashed line. So when we graph it, we want to line up a ruler and just remember to create a dashed line. With arrows at the end, because it's going to continue. And now we have to determine our shading. So again, we want to pick an ordered pair, or an X value in this case, that is not on our line. If we picked the 0, 0 ordered pair, we want to check the value of X equals 0 to see, is that a solution? So when we plug that in, is 0 greater than -1? Yes, it is greater, so because that's true, it is a solution. So we're going to shade everything on the same side of our dashed line as 0. So everything to the right of the line. If we would have checked a different number, let's say check X is equal to -5, if we plug that in, -5 greater than -1, that is not a true statement, so that's not a solution. So we wouldn't want to shade on the side where X is equal to -5. That is not a solution. So we would want the right side shaded. That's just, again, confirming we were correct. Let's try this one. Again, we graph it similarly to an equation. This time, it's an or equal to, so it's a solid line at y equals 2. So we need to find the y-intercept, or y value of 2, which is right here. The y is also 2 here at the ordered pair 3, 2. It's also 2 here and here. All of those points are at the value of y is equal to 2. This time it's going to be a solid line. And we graph it. And again, we want to pick a number that is not on our line for our y values. 0 is not on the line, so we could check that y is equal to 0. If we do that, 0 is greater than or equal to 2. 0 is not greater than 2, so this is a false statement, so we know it's not a solution. So we wouldn't want to shade below the line because 0 is below the line and it's not a solution. So this time we want to shade above the line. Again, we can check to make sure we did that correctly, so we could pick a y value above the line, which would be 3. If we checked 3, y is equal to 3. In this case, 3 is greater than or equal to 2, so yes, that is a solution, and we'd want to shade above the line. Let's do one more. Let's do A, to graph that inequality. We have X is less than -5. So we want to graph at X is -5, 1, 2, 3, 4, 5. It's just the less than symbol, so it's a dashed line. At X is -5. Well, X is -5 here. It's also -5 here, and here, and even way down here. All of those values for X are at -5. Again, it's a less than symbol, so it's a dashed line. Remembering to make it a dashed line. With arrows at the end. And now we have to check for shading. So we're going to pick a number that is not on the line, and because we're talking about X values, we want to pick an X value. So let's check to see. Zero. X is equal to 0. Is 0 a solution? If we plug in 0 for X, 0 is less than -5. 0 is not less than -5 because that's a negative value, so this is not a solution. So we're not going to want to shade on the 0 side of it. We'll want to shade over here. So let's check a number over there just to confirm. So if we check x is equal to -7, we'll plug that in. -7 is less than -5. This is a larger negative number, so it has a smaller value. So yes, it is less than, so this would be a solution. Again, confirming that we shaded correctly at the -7 value for x. Always remember that when we're graphing inequalities, a dashed line for less than or greater than symbols, a solid line for the or equal to symbols.